Hello, this is the Net Hero podcast. I'm Sumit Bose, and this podcast is all about business and doing better for the planet. It's not an eco podcast, we're not green warriors. We believe that business is good and business will make the difference, but it's about holding businesses to account. So if you're interested in what we're doing to try and make things better, to stop our polluting of the planet, to stop our global warming, to stop us driving around in cars that are polluting the air that we breathe, this is the podcast for you. It's all about business, it's about invention, it's about entrepreneurs, scientists, and frankly, there's a few wild cards as well. Do hope you enjoy listening to this episode, and make sure you subscribe and follow us on your social media platforms, and please check out our two news websites, energylivenews.com and Future Net Zero. On with the show. Robots. Well, you know what I think. They're going to kill us all, especially with AI. Today, there's a man who's got a factory that looks like the last scene from Terminator, where she has to crawl through to kill that git. But no, in all seriousness, robots have been with us probably for about nearly 100 years or so, but definitely the last 40, 50 years. And we've seen them transform all kinds of heavy lifting, literally, engineering. You can talk about production lines, the way we eat, our food is packaged, all of these things. And when we talk about kind of where we're going with net zero, mainly we've looked at how we get rid of big things, right? So our power stations, electrifying our transport. But our industry is still pretty much fossil fuel based. You'll have seen, if you've ever been to any factory, there's big machines, the robots, they've got hydraulics, right? And most of that is still running on good old-fashioned fossil fuel. So is there a way that we can take robotics and make it more energy efficient? Well, that's what a company called Rise Robotics is trying to do. And I'm delighted to say I'm joined by a sort of fellow Bengali. He's a fake Bengali, but the CEO, Hitin Sonpal. Hitin, hello, কেমন আছো?
আমি ভালো আছি আপনি কেমন আছেন
আপনি না তুমি That's enough. So before we get into this, what's your background, Hitin? Are you kind of a boffin? Because I know you're based sort of near the grounds of MIT, but are you from a science background?
Yeah, I went to college for computer engineering, and then I've been in the robotics space my entire career.
So before we talk about what you're doing at Rise, I gave a very idiot's view of robots, but I mean, they have been around for a while, right? So I think it must be close to sort of 100 years, maybe a bit less than that. Where did robotics sort of start? How did it start to become something that we've now seen like everywhere?
Yeah, I mean, so obviously the first robots came out of science fiction, right? Folks started to imagine what could happen in the future and thought of more and more complicated machinery and eventually imagining machines that could do things that people could do. And to your point, robots have been around for a long time. You had these chess-playing machines that would essentially have a little person on the inside of it, pretend to be a machine that could be intelligent. So the aspirations have been there for a long, long time. But I'll say that the trend towards humanoid robots and actually turning that into reality is relatively recent. And it's in fashion, if you will, because robots have been around in production lines. They don't look like humans, but they do the work of humans. They're very specialized systems, and they've been helping us for a long, long time. And so what's happened is that the definition of robots keeps changing.
Yeah.
And now when people think of robots, they think of, humanoid robots that look either like Terminator or something like that. But the fact of the matter is that the vast majority of robots out there today don't look anything like humans. They just help amplify the work that humans are already doing.
I think, if I'm right, the word is sort of check or something, but basically they're tools, right? That's how they were started. So I know you sort of studied this. So just for our audience, how did the first robots come? Because Turing invents this sort of the chip and the computer kind of at the end of the war. And then there's a bit of a lull, and then it's all sort of took off. But, you look at the space race, there weren't many robots involved in that, except for when they started to do the lunar landings. So when did people start to think, actually, we can take the computer thing and we can take a hydraulic arm and we can make it do things? When did that start to come together?
That's a great question. So as I mentioned, my background is in computer engineering. And so I can talk about what happened with Turing and so on. That work was around the creation of a mind, right? If you remember, there's this sort of concept of AI and how that's developing. And initially, things that humans could do that we didn't have an algorithmic way of doing were considered to be intelligent. So playing chess was considered to be intelligent.
Of
And
course.
then it took a while, and at some point, there was a computer that was powerful enough with the right algorithms and enough data to then cross that threshold. And people were like, oh, hey, computers will be able to beat humans at everything. And ultimately, the trend has been basically the same. The algorithms get better, the computation gets better, and the amount of data that the machine has to start with improves. And so at some point, they start to get closer and closer to doing what humans are doing. And the techniques, the math, whether it's a machine learning system or a Bayesian system or just statistical correlation, all those systems are just one more tool and one more dimension of what's happening. But it's been a trend that's been going on for a very long time.
In essence, a robot is some sort of computer thing, yeah, with bits that move, right? In the most simple terms. So whether the original, like we talked about production line, lift something, move it, drop something, these are all simple commands that were put in.
That's right.
But when people start using hydraulics as because most of the industrial robots we've got today are hydraulics that we talked about at the beginning, aren't they?
That's right. So the transition to hydraulics is more of a machine-based transition, more of a hardware-based transition.
Yeah.
Before we had machines, we had block and tackle systems, right? So ropes are on blocks and
Right.
tackles, and then you use that to amplify any
Yeah.
kind of lifting and lowering that you wanted to
Yeah.
do. And then at some point, the hydraulic systems came into being, and they could do a lot more than you could do with the block and tackle and rope. And then the curve of improvement in hydraulic systems was much faster. One of the parallels I'll use is electric cars.
Yeah.
Electric cars have been around since the 1920s,
Of
but the
course. Yeah.
battery technology was just very stagnant and the material science was very stagnant. It was easier to advance internal combustion engines than it was to advance battery technology. And it wasn't until laptops started to become popular and smartphones became popular that there was all this investment and demand to have more powerful and more efficient batteries that then eventually drove the transition from an internal combustion engine back to batteries, where the improvement curve is still continuing, whereas the internal combustion engine improvement curve has plateaued, right? So similarly with hydraulics, what you could do with blocks and tackle and rope and cables essentially hit a what I would call a plateau or a local maxima. And then the hydraulic machines kept making progress. And now, when it comes to efficiency, when it comes to speed, when it comes to durability, hydraulic systems have also started to hit a plateau and a local minima. And what has happened, ironically, is that instead of cables and ropes, there are these new belts that initially came out in the elevator space that are now much more stronger than the ropes and cables of the past and also stronger than the hydraulic systems. And so we've hit a new inflection point in this old block and tackle technology. And this is only the beginning because the technology that we use in our systems is very contemporary. But you can think about carbon fiber cables and Kevlar belts and all these new exotic materials that are coming about, that the material science is going to continue to propel at least our technology way beyond where hydraulics is today.
What's the problem with hydraulics? They've been around, like you say, good 50, 60 years. We've all seen production lines and the robots. But are they oil? What's the sort of carbon issue with hydraulics? The reason, your company exists to try and decarbonize. Are they filled with oil? Do they run off generators? Is the actual machinery itself full of fossil fuels? How do they work?
When you think about the fundamental technology, you're trying to amplify force by using liquids, right? And
Okay.
so the inherent physics of it means that when you push a fluid, you're pushing that force shows up in all directions of the
Right.
liquid.
Okay.
That's one issue that is fundamental to hydraulics. And the second issue is when you're trying to move the liquid, there's interactions between the molecules, friction, which creates heat and waste. So the two big challenges with hydraulic systems are actually three. They're energy inefficient because you're losing energy just moving the fluid around.
Gotcha.
Second, you can move liquids only so fast, so they're speed limited. And then third, because this pressure is being exerted in the entire system, the durability is low because eventually you start to develop leaks around every interface. So your valves, your seals, even sort of static contact points will eventually develop leaks because of the high pressure of the hydraulic system.
What is hydraulic fluid? Is it a fossil fuel? Is it like comes from that industry, or is it water? I have no idea what's in the bloody things.
Yes, it is. It is a fossil fuel. It's a very dense kind of oil,
Right.
and it's designed to operate at a high at a wide temperature range. So you couldn't use water because then the hydraulic systems wouldn't work below 0 degrees Celsius, right? But however, if it gets too cold, even hydraulic oil gets viscous, and it becomes even more energy inefficient to run those systems. So there's the temperature range at which it works. There are some applications where you can replace hydraulic oil with something that's biodegradable,
Yeah,
but
I'm going
those
to
fluids
say.
are expensive, and then it doesn't work in all applications.
I'm interested to look at what you're going to do at Rise, and we'll go on to that next. But just before that, just to take on the viewers and listeners on this little journey, thanks for explaining where things are. But obviously, they're massive, right? Hydraulics is everywhere. You drive on a motorway, you see articulated lorries, got the little hydraulic cables. You go to a factory, you see it. Probably in our lifts, in buildings, in elevators, all of that. So, in terms of this industrial kind of heavy machinery, because I think most of us have seen electrification with our eyes, the EVs, the Teslas, and all of that. Or may have seen the closing of power stations, and you see a wind turbine, and you can understand solar panels, electricity. But none of us see this stuff, right? We don't see the hydraulics under the bus or in the lift or any of that. So, how widespread is all this big heavy machinery? And I assume there can't be any of it that's even been thought about being electrical because it's been built to be, big and strong and based on this older technology.
That's right. Hydraulics is everywhere. It's roughly a $600 billion a year
Wow.
market in terms
My
of
God.
hydraulic equipment that's being purchased.
Right.
And to your point, it is the backbone of our economy. When you think about any heavy machine that's pushing, pulling, lifting, lowering, there's a
Yeah.
hydraulic system behind it today. When you think about a bulldozer, right? But the part that pushes on the ground is hydraulically driven. If you think about an excavator, the bucket and the boom arm,
Yeah.
that's all driven by a hydraulic system. If you think about a garbage disposal truck, the press on the inside is driven by a
Yeah.
hydraulic
Cool.
system.
It's everywhere around us.
If you think about mining machines, they're all driven by hydraulic systems,
Yeah.
including the steering, because those machines are so heavy. Think about an aircraft carrier and what it takes to take the plane out from the bottom of an aircraft carrier to the top. Well, that's a hydraulic lift. So, and submarines, when you think about the surfaces that have to get moved, right? There's a lot of hydraulic equipment just across the board because anytime you need to move something in a straight line with a lot of force, the technology of choice till today has been hydraulics. But going forward, it's going to be us with our Beltrolic technology.
What's the problem with this? Because some would say this has been around. I know you talked about there's some leakage and there's some energy efficiency, but they work. And also, flipping egg, if you said to me, hey, Sumit, be net zero, rip all your out and put it, people go, no, no, no way, I'm buying all of this stuff because it's all part of the fabric of a building or a fabric of a factory or whatever. So when you talk about kind of how we kind of go towards net zero, your solution at Rise, and I want you to talk about this kind of belt. I think you call it Beltrolic. Is that right? Is that the name for it?
That's correct.
Yeah.
Yes.
Before we talk the actual how it works, is it a solution for someone building a new factory tomorrow, or is it something that can go into the place behind you right now and replace some of that machinery there? Because that's the thing that a lot of business would say, hey, we'd like to do this, but I can't afford to rip all of this stuff out and brand new stuff. So is it a retrofit solution? Or is it only for a new build or a new machinery, a new plant?
That's a great question. So let me just take a step back and talk about net zero, right? And I'll use
Yeah,
an example of the state of California.
yeah,
California would like its ports to go net zero by 2030.
yeah,
That deadline is likely to get extended. But what's happening is that when you try to build an electric machine around a hydraulic system, the price doubles, right? So
yeah.
if you have a $400,000 system that's diesel and hydraulics, the you end up adding $400,000 worth of batteries onto the system just to run that system, for an 8-hour shift.
Unaffordable. Makes no sense, yeah, financially.
And so to incentivize companies to do that, the state of California gives out vouchers, but those vouchers get sold out in the first 2 weeks that they're
Of
issued
course.
because those are the only 2 weeks that most of these companies buy electric equipment, and then they switch back to the gasoline and diesel powered equipment because they can't afford the electric systems. They're just not viable today. And that's where our technology comes in. Because we're 3 times as efficient, at the system level, we're roughly 2x efficient. We cut the size of the batteries that you need to build an electric system by 50%. So instead of being an $800,000 machine, it's now a $600,000 machine. But
Gotcha.
wait, that's only part of the benefit. The other part of the benefit is that the charging infrastructure, that's cut in half because you're not charging your systems as much. You're not drawing as much power from the grid. Then the grid upgrades that need to happen to support the electrification, well, now you need to do half as many upgrades. You don't need to double the capacity of the grid. And then back to power generation, if you're trying to electrify, you
Yeah.
need half as much as you thought you needed because you're using RTech. So that's why it's core to this transition to net zero for heavy machines.
How does this belt hydraulic you talked earlier about, you make a, instead of the tube, right? I'm trying to visualize it so that people can listen and understand. People can imagine a robotic arm, right? And it's got the liquid tubes that go through it, right? And then they move and they push things. So what are you replacing it with?
So what we've done is we've taken out the hydraulic oil from these linear actuators and we
Yeah.
replaced them with belts and pulleys. So there's a block
Okay.
and tackle system and then a belt instead of a rope. And these belts are built out of steel rope and plastic on the outside. And so
Okay.
the steel is sealed
Uh-huh.
and uh, and it lasts forever, essentially.
Right.
And the friction in the system is all very intentional. So our actuators are 90% efficient just when it comes to the mechanical input in to the work that it can do. And then you add a motor to it. Motors are typically 85% efficient. So our total efficiency for a belt hydraulic actuator is 75%. Typical efficiency for a hydraulic system is 30%. So we're roughly 3 times as efficient. Yeah.
Wow. And so the machinery, it does the same thing, right? So if it's an arm that picks it up, it used to have a hydraulic liquid that pushed and compressed. You replace it with that cable. What's pulling that cable? Because obviously you mentioned the liquid gets pushed. So how are you moving the actual cable now then with your technology?
Yep. So we end up instead of pushing, which would be a liquid under compression, we end up with belts, which are fibers in tension, kind of like a muscle. So even when you're pushing with your body, you're something is pulling somewhere, right? And so that's what we're doing. Instead of pushing the liquid on both sides of a piston to make it go forward and backwards, we end up having cables that pull the piston in both sides and make it go forward and backwards. The output looks the same, but the insides are very different.
So you've now lost the actual fossil fuel because you don't have that in the cable.
That's right.
You talked about, the points of pressure. So does this still have the same failure or is it much more stronger? And the final point is, durability. How long will this stuff last?
So the failure mode is very, very different. If you think about a hydraulic system, the typical failure mode is leaks, but then
Yeah.
other failure modes, which are more catastrophic, are when hoses burst and you end up
Yeah.
spilling hydraulic oil everywhere. If the hydraulic oil is under high pressure, you can cause injuries. So for very heavy machines, all of the operators have to wear personal protective equipment because hydraulic oil can really kill them at any point.
Yeah.
And we don't have that. Our major failure mode is that the belt ages over time. And at some point, the belt gets close to breaking. However, in our designs, the belt don't actually break. What we do is we put electricity through the steel ropes inside of the belt, and we look at the electrical properties of the belt. And so even before the belt fails, we're able to tell the operator, it's time to service this system. We're not going to operate anymore. But you couldn't do that with the hydraulic system. And it's dramatically changed how people do maintenance. If you think about how maintenance used to be done in the past, it was all reactive maintenance. Something
Yeah.
broke and you
Yeah,
fixed
you
it.
figured. Yeah.
Then folks got smarter and they started building in models and they started to do proactive maintenance. But with proactive maintenance, you know that you're going to do maintenance of things that don't need maintenance because they're not broken yet. So you're leaving some money on the table. But what we do is on-demand maintenance. So the machine tells you it's time to invest some time and money right now before things get much worse.
I get it.
This is the holy grail of maintenance. You can't get any better than this.
So it's sort of like a just in time that people
That's
have
right.
in the food. So you fix it before it's going to go, but not so early that you're wasting your money and not too
That's
late
right.
when it's already gone. How do you save on energy? How does your system save on energy? So the actual carbon footprint of your system.
Yeah. So as I mentioned, we get to 90% efficiency just in the core actuator. And
Yeah.
that what happens there is that all the belts are sitting on pulleys. And the pulleys are connected to bearings. And bearings are a well understood science. We know how to make bearings that are 99% efficient. Um, we have 5 to 10 of them in the system, and we are able to get to a full 90% efficiency for the actuator.
And in terms of power, diesel, we start it up, off it goes, or you pour gasoline into something and off it goes, and that moves the arms and all of that. Are your systems built to be only powered by batteries, or are they sort of a hybrid that could still be powered? Obviously you don't want to do it, but for some people there'll be a cost. So how have you thought about that?
Our systems are predominantly designed to be powered electrically, but that doesn't mean that you couldn't power it off a diesel machine or a diesel engine that's connected to a generator. You could power it off a hydrogen fuel cell. You could power it off batteries. You could power it off grid power. You have lots of options, and we're flexible about those. We really want to be where the customers are at. We believe that energy efficiency will save them money. And that's
Yeah,
really the business pitch. We don't necessarily talk about net zero and cleanliness.
I
Those are
get it.
things that motivate our employees. But for our customers, we talk about the maintenance that we're going to slash, the operating expenses that we're going to reduce, the energy costs that are going to go down, and the productivity gains that they're going to get by going faster.
So, in essence, what you're trying to do is, and correct me if I'm wrong. I'm getting this picture now that you're saying actually heavy plant, heavy machinery. We can make the machinery itself more efficient. We can make it. I haven't talked about price. We'll talk about it in a second. But we can make it more durable. It's more smart, so it knows when it's going to go. And you have the choice whether you go super clean by using battery and fuel cells or whatever, or if you happen to have still that system, you can still use it because there is, I've always believed that this will be a transition. You can't expect to get people tomorrow, but we've also not got to encourage people to keep using the old systems. So where do you sit on that? How, because I think you're sort of, from what you're saying, you're kind of fuel agnostic.
That's right. Yeah. So, and this actually goes back to a previous point you had brought up about retrofitability,
Yeah.
right? Our cylinders are just a little bigger than hydraulic cylinders. And
Okay.
so, in applications where the cylinders are on the outside,
Yeah.
they're very easy to retrofit. And often, hydraulic cylinders are on the outside because they need to be serviced. Like if you think about an
Of
excavator, you can
course.
see the hydraulic
You
cylinders, you
can
can see
always.
the hoses,
Yeah.
right? Um, and then there are applications where the cylinders might be buried. And so, for those applications, you do have to redesign the machine.
Okay.
And in some applications, the cylinders are so exposed that no machine change is needed. So our first commercial sale, which happened last year, is with an oil and gas OEM, and
Right.
we're helping clean up their energy production. And their hydraulic cylinder that they're replacing was completely exposed. So they had to make no changes to the machine to incorporate our cylinder. Whereas if you think about an excavator, you'd have to change the mount points.
Yeah. Yeah. Of course.
And then we're working on a product that's a lift gate where the cylinder is buried. There are 3 walls around it. So there was a fair amount of redesign required. So
Yeah.
it's different depending on the application. And then as far as price point goes, we had a study done by a company called Danfoss, whom we're partnering with on some projects. And they determined that at scale, our systems would cost 50% more than hydraulics. And I mean the Beltronic technology itself.
Yeah.
And then at the machine level, the impact would be much, much lower.
Why would I do it? I'd say, hit it. I like it. It sounds great, mate, but I ain't paying more. Why would I want to do this?
But the total cost of ownership is much lower. I'll use an example. One of the products we're working on, and we just finished a pilot with, is a lift gate. The lift gate goes on the back of trucks.
Right.
And our pilot customers are in the food and beverage sector.
Okay.
On average, they're doing 18 stops a day, and the operator is spending an hour on the lift gate going up and down.
Well,
Our lift gates run twice as fast. Now the operator is spending only 30 minutes a day going up and down, and all of a sudden they have time to do an additional delivery. That's more revenues,
ah,
right? And depending on the business model, that could be worth an additional $300 a day to $1,200 a day. And the return on investment is 6 months for that product.
wow.
That's why you should do it.
Will it last longer?
Yes, it will last longer. Our current estimates are twice as long as a hydraulic system and 5 times as longer as long as a screw type actuator, which is this alternative technology that's being used to replace hydraulics.
What's your hope for this? Because I know you've sold some of this to the Department of Defense in America. There's a few other clients you've got. I'm assuming it's doing at present. Is most of your stuff going into heavy lifting, or is it also gone down to very small scale stuff? What are you selling? Big stuff for moving big things, basically.
Yeah, we're on the, I'd say, on the bigger end of the scale. Our smallest actuator can push 2 tons, and our medium-sized actuators can do about 20 tons. And our large-size actuator, we haven't built one yet, but the math all works out, should be able to do 50 tons. And
Wow.
because we can control them very precisely, unlike a fluid-based system, we can parallel them up. So we can have 4 actuators that are all 50 tons pushing 200 tons, no problem. One of the things that we did for the Department of Defense is build them part of a robotic arm that goes on a munition handling unit, and that robotic arm can lift 7,000 pounds. It's actually the world's strongest robotic arm.
Wow.
We set the Guinness World Record for it in March of last year.
Congratulations.
Yes, thank you.
I get it in terms of what you've said, which is it'll help keep things going longer so there's less service. It is good for money, which is important, very important for businesses to make money to do that. But what do you think? You said that you don't really sell it on the kind of net zero angle, but I know you as a company are keen on that. What would you say to critics saying, well, what are you doing for the environment? What are you doing that makes, you know, the world of industrial robotics a little bit cleaner?
Yeah, energy efficiency drives everything. So if you can make the energy more efficient, then there isn't global warming happening, right? That's the key. And the second piece is that the reduction in operational expenses for these heavy machines that drive the backbone of our economy ultimately reduces the cost of goods. And so we're improving the quality of life for everyone by reducing the cost of products and also cleaning up the environment at the same time.
I think you're at profit level now, yeah? You're making some sort of profits, or you've made some commercial sales, or you're not quite there.
We're not quite profitable. We had our first commercial sales last year, and we're hoping to scale that
Yeah.
aggressively this year.
And you're looking to do this using people as well, asking people to get involved. Is that right? So it's a kind of, old school crowdfunding sort of idea, which is quite interesting for this kind of technology.
That is correct. We have opened up our last round that we made available to institutional investors, to the public. In the United States, there's a law called regulation crowdfunding, which allows companies to let anyone invest in them. And that's what we've done. When I joined the company, we had 1,500 followers. These were people that were excited, including folks that delivered stuff to us and came in and saw what we were doing and asked if they could participate. And at that time, we didn't have anything. But shortly after I joined, we opened a public round, and it's been very successful. We were the number one regulation crowdfunded campaign of last year. We raised over $5 million.
Wow.
And then we'll soon be opening another round. And if folks are interested, they can check us out at our website.
What's your hope for what you're doing at Rise Robotics? What's the ultimate aim?
I want to leave a dent in the universe, right? I want to be one of the folks that has managed to make a big impact on global warming and also found a way to make things more affordable for everybody. I think those two things drive me every day. At the company level, I'd love to make this company into a unicorn in 5 years. That's getting to 100 million in commercial revenues and still continuing to grow. So that's our target. And that's what I've rallied the team around.
And all the gear behind you, I hope you're using all your little belt drive technologies. If there's a single hydraulic unit in there hitting, I'll be very, very annoyed.
We have one pneumatic system, which is also fluid based, and we're using it to test our actuators. But that's
Okay.
it, just to make sure that we have a benchmark. Yes, but the red cylinder that you see
Yeah, yeah.
back there, that is the 22-ton cylinder. It's connected to a forklift test stand. There's no forklift attached to it, but there's a test stand there. And there's a bunch of test equipment in our build area in the back. This lab is one of the reasons why I was excited to join the company.
No, I love it. It's good. I think, like I said, it's brilliant to see someone with some stuff still being made, not just a bloody green screen. So, yeah, well done, mate. Listen, best of luck with it. I think it's very interesting. It's not an area we've explored on the podcast before, but you're right. I mean, it's everywhere when you think about it. This huge industrial robotics and all of that. Just make something that doesn't look like Arnie whenever you've finished. Yeah. All right.
Yes, that's right.
Maybe make it look like a Bollywood star. That would be a better one.
Sure, absolutely. Yeah, I'll pass that request along to the engineering team.
Yeah, thanks on it. Listen, Hiten, thank you so much. I'm wishing you and Rise Robotics. What's the website for people who want to check it out? What's it called?
RiseRobotics.com.
Right, make it nice and simple. Brilliant work. Thank you for your time. Thank you for joining us from near Boston. Best of luck with what you're doing. All the best.
Sumit, this was a pleasure. Thank you so much.
Namaskar.
Namaskar.
Let us know, audience, what you think of it in Hindi, in Bengali, in English, whatever language. What are you doing in terms of like industrial? Have you looked at your industrial kind of sites and thought about stuff? And check out what they're doing in that. My thanks to Sohi as ever for production this week. We'll be back with the next episode of the Net Hero podcast very soon. Remember to subscribe.
You've just heard the Net Hero podcast from FutureNetZero.com. Join us as we help you find ways to cut your carbon footprint as we head towards net zero. Subscribe and follow us on social media. FutureNetZero.com. Better business, better planet.